everybody, let's try this example. So I picked this one because there's a load being applied directly at a joint of this frame. So I wanted to make sure I covered an example like that. Okay, so what do we do? Break it apart. All right, so we got this part. And then this kind of horizontal part. And then this one over here. Okay, so there's point A, B, and then D is over here. Then B is over here, E is over here, and then, let's see, E is over here, D, C. Okay, and now there's the two loads. 60 pounds right here, definitely goes right here. But where does this one go? It's acting at point E, which is here. So it's either here or here. You pick one or the other, not both, and you're fine. So whichever place you want to put it, doesn't matter. You can put it here and you're good, or you can put it here and that's fine. Just pick one. Okay, so I'm just picking one. Okay, so forces are acting at 3 points here, 3 points here, 3 points here. So now, let me start labeling everything. So if I pick coordinates, let's say X here, Y here, let me decompose the reactions. Okay, so there's pin A. I'll decompose into X and Y. There's pin B. I'll decompose that into X and Y. There's pin D, same. All right, and then because I drew like this, here's pin B. I have to draw these equal and opposite by Newton's third law. Okay, and then same story. D is also here, so I have to draw these equal and opposite. All right, and then there's point E is over here. And then that is also here, so I have to draw those equal and opposite. And what am I missing? Oh, here, the roller at C. So that has to be normal to the surface. Okay, let's see. Do we have everything? I think I got everything. Yeah, okay, pretty sure. All right, so now let me just move this where we have a little more space. Okay, so now we can sum forces in X, Y, torque. Each of these we can write 3 equations. Right? And as many as 3 equations. All right, so, well, since I'm already here, so X direction minus VX plus EX. Is that it? That's it. Okay, Y direction, negative BY minus 60 minus another 60 plus EY. Okay. Okay, so let's sum torque about somewhere clever. There are 3 forces acting right here. So I'm going to sum torque about point E. Okay, and then just I want to point out the way I pick my coordinates, Z would be out of the page, so in counterclockwise. So the torque by this would be positive. Okay, how far is that? 8 inches. Okay, so 8. Positive. 60 pounds. And then the torque from this would be 0 about point E. So then there's just this plus 16 BY. All right, let's take a look at what we got here. So look, there's only one unknown, BY. So solve for BY. So we got that. Substitute it right here. And then there's only EY, so you can solve for EY. And that's as much as we can do here, right? Because now we have two more unknowns for that one equation. So we're stuck for the moment. Let's go to another part. So let's go with this one. So in the x direction, negative EX minus DX plus C. Y direction, negative dy minus EY. That's it, equals 0. All right. And let me point out, see here, we already know EY. We already know EY. So we got this already, which means, look at this. You can solve for dy. Done. Okay. Okay, so let's be clever here. If we sum torque about point D, then there's no torque from C or dx or dy about point D. There's only torque from EY, which would be in the negative z direction, so negative. And then how far is that? 16 inches. Negative 16 EY. And then there's torque from EX, which will go in the positive z direction, so plus. And how far is that? 8 inches. So plus 8 EX. Okay, and then again, we already know EY. So take a look. There's only one unknown, EX, so solve for that. Okay, and then look. Right, so if we know EX here, now we know EX here, and now if you look at this, there's only one unknown. Right, so we know EX. So there's one unknown left, BX, here. Okay, and here we know EX, but it's not enough information to solve for these remaining two, but that's okay. Let's go on to our final part over here, and then let's write, okay, x direction, AX plus BX plus DX. Is that everything? Yep. Okay, y direction, AY plus BY plus DY equals 0. Okay, before we go here, let's take a look at what we got so far. Okay, dy, look right here. We know dy. Okay, that's done. So, right, look, see this part? We know bx, by, ex, ey. We already know these two. So I'll just make note of that. And then we don't know C or dx. Let me mark a different color. We don't know this, or right? Okay, so what should we do? What would be clever? So, oh, I didn't finish here. So, again, take a look at this. We know by and dy, so the only unknown left is ay, right? So we can solve for ay right here. So that's good. All right, now take a look. We only have two unknowns, this and this. And we can write an equation here. So let's sum torque about somewhere clever, either at A or at D, whichever one. Doesn't matter. D. Okay, sum torque about point D. So there's torque from BX, which is in the negative direction, 8 BX, and then there's torque from AY, which is also in the negative direction. And see, here to here is 8. And then there's torque from AX, which is in the negative direction. And here to here is 16. Okay, and then we already know bx, we already know ay. The only unknown left, ax. Okay, so solve for ax. Got it. Take that value, plug it in right here. And then the only unknown is bx here. Right, so now we know everything here. And now that we know dx here, that value goes right here. Right there. Here. Now take a look at this. There's only one unknown left, c. Here. Here. Okay, now we know everything everywhere. Right, we know all the reactions for every member of the entire structure. Okay, so keep on practicing. Pay attention to the method more so than like the math part. Okay, so I'll see you in the next video.